Hi, welcome to my talk about Apache APISIX ops. In the next nearly 40 minutes, I would like to take you on a ride towards the things about API ops and all the parties involved. So we see a lot about API definitions, we see a lot about API gateways and all other things we need to know about to do API ops, so nearly operational things. My name is Kocot and I work for Kocot in Germany, and at Kocot I'm in the role of a senior solutions architect and head of API experience and operations. If you would like to get in touch with me, you can do it via mail, Twitter or LinkedIn, and maybe we can start a conversation and talk about things in consideration of the things we talked about today, or I talked about today. But what would we like to talk about today? What are the things that might be important to us? For that we have this little small diagram which shows API ops in actions. We see that we have 4 phases actually around. We have a design phase, we talk about CI/CD, so the pipelining thing, and in the end we have something to deploy. And doing this, we certainly kind of do things like we do linting, we talk about unit testing or testing, we talk about policy enforcements, we would like to generate configs and even would like to deploy configurations and definitions around to the certain kind of parties involved. So on the deployment side, we have a really deep look about infrastructure. So we see some things like a gateway, a portal, maybe something else like a hub or something like that. And even when we think about deployment, we could also deploy something to a marketplace actually. So this is what we see in the scope of API ops, so the operational thing, which only consists of the last 2 phases. So we have a deep look into CI/CD pipelining and the deployment phase. We drop the design phase. So all the tools we see here, like Insomnia, Stoplight Studio or Portman, are not on real focus for us. So we focus more on the things we would like to do when we think about operations in consideration of APIs. So what we would like to do is, when we think about CI/CD, we would like to go in a transformation to automation. So for this, we have to look at API first, actually, what it means, what is the context for API first, where are we heading. Then we have to think about, for consideration of automation, of a Git process actually. For this automation process within the CI/CD pipelines, we need well-structured and formed API definitions. And we have to think about automated linting. So we will see what is all about. And then we have to think about automated testing also. So not only the linting part for validation and all the stuff behind that and having policies around it. So we also have to think about how to test an API in an automated way. And after linting and testing, we can really think about the deployment of relevant infrastructure which is involved. So these are the steps we have to go through if we think about the transformation to automate things within CI/CD. And this is what we would like to do in the next minutes. So what is API first? When we think about API first, everybody's talking about, we talk about companies who are API first. We talk about initiatives who think they're API first. What does it really mean? So at first, an API is often the only interface to users of an application. So we don't have any UI or anything like that around. So we communicate directly with the API. And in regards of API first, the API comes really first. So there is no implementation before we have this API considered to be. So the definition must be really first. And an API in reference to API first is described and documented or really self-descriptive. So we have to really think about that we describe all the things we would like to present to the outside to say, okay, this is what you can do with our API. So we have to document it. or we have to think about, oh, maybe it's self-descriptive, so we don't have to think about too much about documentation actually. So that's an easy part. Even the part with Git is quite easy. So everybody should know Git, so version controlling and all the stuff behind it. And for what we would like to do, we need some kind of Git flow. So I wouldn't like to give you an introduction to Git flow, so you can mainly Google for it and see what it's all about. So we need some kind of it, which means in some circumstances that there are no direct commits to a main branch. So everything we would like to do now and in the future, we would like to have a good branching model for history, descriptions, and all the stuff around, so that we really know what it really means to look at it and say, okay, no direct commits to the main branch. And every change, we see it here, to the definition or specification and the pipeline has to be a pull request. So we need, every time we do things in combination with the pipeline or up to the pipeline, has to be a pull request, so that there are people maybe involved to give a review and talk about things and nearly lift up collaboration actually, so that everybody who is involved in the process knows what really to do about and really think about and say, okay, it's easy to go this way, and really make it clear for everyone involved actually. So when we think about a well-structured and formed API specification, that's actually not the easiest part so far. So we have to set a focus actually, to not really overburden the things we see around in context of gateways and so far. So we focus actually on RESTful or REST APIs. So what does it really mean? So when we have a look at the Open API map from on the API handyman, we see what is happening towards the Open API specification. And somehow it seems to be a very simple type of thing, but when you look deeper into this Open API map or specification, it gets complicated and it's getting complex so far. So we have to be aware of the things in reference to an Open API specification or a definition we actually write. So normally when I talk to people, they always say, oh, we do code first and we just create an API specification or definition and say, yeah, that really works for us. And I normally say, do you validate the specification or the definition you create actually? And sometimes they say, yeah, we do, but we left it because what we created by some generator, it's not really fitting towards the validator actually, so the linting doesn't work quite well. So that's a really good point to really say, okay, we have to start with API first and get knowledge of the Open API specification. But you haven't to be the greatest crack around with talking about Open API and the definitions or the specification so far. So there are a lot of tools helping you to really establish a good understanding of the Open API specification so far. And there are actually methods available which make it more and more easier to really create these well-structured and formed API specifications or definitions. And the easiest part to really think about is just splitting the structure for reuse and for better overview. And in the end, for the reuse thing, or for the reusability, we create a design library actually. So what we create is a library where everybody who is involved in the space of creating APIs in an organizational context can rely on the design library. That's a quite good example when we think about error messages and so on. So it might be good to have a generalized error message library to make sure that everybody in a company or an organization talks about the same thing when using HTTP status codes. And that's a good starting point really to think about how could I reuse things that I created within my specification to make even other specifications in the future better, or getting traction to it, and not to restart everything on my own actually. So this is one of the things we can have a look at it, to say, okay, we have a design library actually so far. And another interesting point is, we talked about splitting. So I need to use something for referencing things. And in the context of OpenAPI, we have this ref parameter, which makes it easy to really focus and say, okay, we have a reference to something. And the reference could be local within the same file actually, to say, okay, we have stored something under component schemas, and there is my element. But I could even say that I have a remote reference that is lying on the same structure where the OpenAPI definition is placed. So I just can give a remote part and say, okay, you find that, and you can there, and you can use it really in this way. Or you can really go further and say, okay, we create a design library as a second repository in our Git, and we can use it and rely on it, and can say, okay, just use the reference to a URL and say, okay, use the raw thing you find on our Git system, even if it's GitHub, GitLab, or Azure DevOps actually. We can use the URL to really get a focus on it and say, okay, somebody else made this element and we can just reuse it for our own. Another point is the use of so-called OpenAPI extensions or extended fields or X-objects, whatever you would like to call them, to handle your own and vendor-specific needs. And this is something which makes the OpenAPI specification really powerful, so we can really give it more a complexity in the things about our own company, our own organization, to really make sure that everything what we need for the OpenAPI specification or for an OpenAPI definition can be put into it, and we could be aware of the things we see within the OpenAPI definition for a service we created. So with this X minus vendor, and then we have this X minus, and these fields are supported on the root level, at the info level, paths, operation parameters, responses, tags, security schemes. So we have a wide level of using these extensions so far. In projects, we use these extensions a lot actually to really focus on it and then say, okay, we have a portal, and in this portal we have a structure or something like that, or we have other tooling which relies on the information in the extensions field, so that we are able to really use things that were provided by the definition so far along the APIs. So, and having a look at this descriptions we could now create, we see that it's mainly our goal to move further to have something you normally call configuration as code. So we have this description, which might help in some cases as a single source of truth in somehow, and which makes it easier for us to get the information to the infrastructure. And for infrastructure, it's mainly configuration as code. We will see how it happens here within the APISIX universe. So this is something we could rely on, but maybe we see that's quite different, and we see what is possible at the moment. And so, but our main goal would be to really move from the API description to configuration as code. And for this, we need linting. And this linting should be automated, which means that it runs over a pipeline, not on my own notebook, MacBook, or PC or something, on my own hardware actually. So we need it in the pipeline. And to have it in the pipeline, we have actually two options. We have OpenAPI CLE and we have Spectral. The two tools are open source, and with OpenAPI CLE and Spectral, we are really able to create consistent, valid, and high-quality API descriptions. And why could we create this? Because of everything is covered by rules. So normally these tools, these two tools we saw the slides before, have rule sets in combination with the OpenAPI specification. So we have a format for 3.0, 2.0, and we could extend the things with the things Spectral or OpenAPI CLE brings with, or we can create our own rules to create real rule sets actually, or plugins, which is called in the OpenAPI CLE world. So with this ruling and the rule sets, we are able to create our own governance, hopefully covered by API guidelines. So when we use these rules or rule sets of a lot of rules, actually, this leads to API guidelines, or it covers API guidelines which still exist. So hopefully we have some API guidelines, and hopefully they were not just copied from somebody else, so they really fit to our organization or company actually. But we could also go the other way around and say, okay, we don't want to have the things actually, sorry for that, we don't want the things actually to happen so far, and we really want to start with the rule sets actually, because we don't want to think about all the stuff that's written down in the guidelines. There's a lot of text actually. Maybe we just start with the rule sets and say, okay, this is what we need. And in the end, the good thing about the rule sets or the rules is that we can cover them with a version control system. So we are always in control of these rules because they're covered by our version control. And this is what it makes it really important to us, not just having this written down document by saying these are our guidelines and nobody is using it, and a lot of people ignoring them and say, okay, they want a lot of things from me, but I can't, and I don't have to, I want to think about versioning, I do the things I would like to do on my own and all the stuff. So, but with these rules and rule sets or plugins, what we would like to call them, in combination with the tooling like of Spectral and OpenAPI CLE, we have more power control to really control the guidelines actually so far. And this is what makes it more consistent to have such automated linting so far. Because this automated linting leads somehow to testing. So when I have a linted API definition, which is valid and has all the properties that I wanted to have within the description, I can now retest the description. And in reference to the starting point of API ops, we want to have it automated. And to bring up a little spot into it, the easiest way to really automate things around in the way of testing, not to create your own test set with BDD framework or something like that, is really using Postman collections. So the Postman collections become a contract within the testing context. So what we had earlier with the API specification or description we created, it's now that the description changed to is transformed to a Postman collection, which now becomes the contract in the testing context. And the Postman collection is the foundation for variation testing and integration testing, which is also possible within Postman actually. So we have a possibility to really use it and create good things around and make it clear that we have this testing combination. So everything is relying in this case on the Postman collection. It's in general the foundation for variation testing and integration testing so far, because we only have to write tests for the Postman collection themselves actually. So this is what I said so far. So our goal is now to convert API description to Postman collection. Yeah, somehow it is solved, but just converting something to something else isn't in this case enough. We should only convert descriptions to a Postman collection when the Postman collection runs a contract test, and then everything is green, and then the Postman collection is created and presented to other users actually. So, and to do this, we can use a tooling called Portman. With Portman, we are able in our pipeline to really do this. So we have a specification. In this case, it's called use YAML. And we can have all the things around. And the good thing about Portman is that we are able to run human tests based on the Postman collection we created. So what happens here is that a Postman collection is created and set directly on the test. And only when everything here is green or we have this marker, then the collection is written to a place to output we set up before to output folder. Here's in the easiest way, we have a temp ordner and say it's converted. And with this, we have actually a contract tested API description based on a Postman collection so far. And with this, we get a Postman collection, which can be used for further testing and ongoing testing actually. So we don't have to create our own test set and create our own test suite for every API we create actually. We just have the things around that we can say, okay, we have a description available, we create a Postman collection from that, and then we can set the Postman collection under test, so the API itself is tested throughout the whole process. And this is what it makes it quite easy to do the testing so far. But maybe this contract integration and variation testing is not enough. We mainly have to think about something else, which goes into the direction of load testing. So a tooling called K6 comes up. And K6 is a tooling which comes from the Grafana team. And with K6, we are able to really create smoke tests, load tests, stress tests, and soak tests. And the good thing is that we are able to convert our Postman collection to a simple K6 test. So just the easiest test available. With the tooling around, you can configure more things, but in this case, it's just the easiest test to create. And the JavaScript file can now be used for more compromise testing and further ongoing testing to make clear that everything goes into the direction of a load test towards the created API actually in reference to the backend system we use there. And I did a little small test locally to make it visible for all of us. And we can see here that K6 is able to, or makes it easier to create a scenario and create virtual users and to do a real load test over time. In this case, it's just about to say, okay, the API description sends data back and forth. So the API is really working with, in this case, a mock server behind it. It's just a really smoke test, just to blow things up and say, okay, it's working. But we can go more further and say we also want to have a soak test and really soak over time and all the stuff, which is configurable by just using the test JavaScript file actually to make sure that everything is under control. And with the step we saw earlier, so that we started from the description, got to the Postman collection, and move now to the K6 tests, it's really easy for us to do this because we don't have to change so much around. So we just create little frameworks for testing so that we can move further with the own test kit actually. So in this case, we could elaborate on more K6 testing so far towards the API when we go further on the steps towards API ops actually. And with this, we have now a well-formed and structured API definition, which is already under test. Now it's the interesting part to really think about deployable infrastructure based on an API description. How does it work? And what infrastructure component can be maybe described via an API description? In the case, we can talk about gateways, portals, hubs, and registries, and maybe marketplaces. Yeah, so this is something we could also have a look at it. It's also possible to really deploy infrastructure, whatever that means. Yeah, deploying a gateway on our own with each API product we provide, or just to add configuration to an existing API gateway, to an existing portal, and so on. So we are able to deploy things into infrastructure based on an API description. And now let's have a look more into API 6 to get more into the deep. So with API 6, we have the possibility to use extended fields. This is something we talked earlier about. So with this, we are able to really establish this single source of truth based on the API definition. And we can map the API description to the API 6 root properties. So with this, it makes it really easy for us to understand how to configure the route in API 6 based on the description for the API actually. So it's quite easy to understand, so we don't have to think about, I have to install a gateway and so on. So it really can consist and be there, or just deployed by creating configuration as code and all the stuff, or being based on the API description. And let's have a look at maybe simple examples. This is an open API description for a published route. We see that we have just a simple open API description, and we have service, we have an info, and all the stuff we know. But then there is something which is not normally found in an API description. We have here this x minus API6 upstream property, which describes the upstream for the route we now create. And you can see here with the markers, with the comments here, that we have now here the route URI, we have the route method, we have here a route description, and the operation ID of the path actually creates the route name. So it's good to know that with this operation ID, the route name will be placed actually. And with the x minus API6 minus upstream, we are able to define the route upstream actually, and do things underneath it and say, okay, we have a type and we have nodes and all the stuff available, and this is what we need. Then we have this API6 status property, which will make sure that when we import the API description, the route will be published. So this is something which is quite good actually. So when we create an API specification, and we could say, okay, we are not quite sure if we want to get the description published in real, we want to have it on the gateway so far, we can use this to make sure that the route is available after import but not being published. And here we see that's quite a normal stuff. So we have a lot of things actually here around. So it's a normal type of thing to really have a published route. Then we have the possibility to have a route with plugins actually. The route with plugins has just an addition to say, okay, we have this APISIX minus plugin, and then we have the name of the plugin so far. So in this case, we have a limit count with the key to remote address. So everything stays as it is, and we just add the plugins actually we need for the routes to make sure that they are available actually for the whole thing we would like to have actually. So we just define the plugins to the route and know that the plugins are now available to the route actually. And nothing underneath changed. And we go further. Normally we need authentication plugins with the specification or the definition so far. It's quite easy because we have the security properties for the routes actually. So for the path, we see that there's the security. We could do basic auth, API key auth, and bearer auth. And what we do now is that we just declare what is needed within the component schemas and say, okay, this is our security schemes. And we make sure that the information now exists under the route actually, or the path, in which case we are actually looking at it. So this is what we can do towards the API description so far. So we are able to really configure our routes for the gateway by just using these extended fields to really make sure that the description knows every parameter for the route within the API gateway so far with APISIX. But when there is some light, there's sometimes maybe some darkness. So what we see now is the actual state of automated deployment with APISIX. What we can do, we saw it earlier, we have the API description with additional extended fields, but we have to place these descriptions in a folder or a bucket, because we only can upload these specifications for now. I know the guys are working on version 3 and this will change actually, but for now we are only able to upload the descriptions via the APISIX dashboard. So this is something which could be done manually, but this is a web interface, so maybe there are some things around like RPA or all the things, robot process automation things, or anything like that. So, or maybe some Selenium or something like that around, that it maybe can be automated in some case. The good thing is, after we uploaded the information to the dashboard, it's available to be exported through the APISIX admin API. So we are able to export the configuration and use the configuration file as a single source of truth actually. So with this we are able to bring it more up. So we talked about API first and all the stuff about API description so far, but what we actually missed and wouldn't bring us into a different direction actually is to think about products, API products. And with this possibility to have to really export the configuration needed for an API product and to have it stored somewhere, we are able to create one configuration file per API product to really make sure that we can drop it everywhere we would like to do. When we have different zones or everything like that, we have one configuration file per API product to make it easier to really make sure if there is anything that has to be imported again, that it really fits to the API product we created so far. So that's the actual state of automated deployment with API 6. But looking at my clock, so we are nearly to the end. We have also some missing parts. We didn't look at policy as code. So integrating OPA with API 6, this is something we didn't spot, and I think there is something available like a blog post on the API 6 blog so far, when I remember it correctly. So there is already something to find about, but this is what we actually missed. So we didn't talk about policy as code or this policy thing so far. So it's not this what we covered actually. So when you would like to wrap up things and learn about the stuff I'm actually talked about, you find several blog posts on the Codecentric blog. You can really use this URL you find there, and with the information there, you get all the things Codecentric is thinking about and myself I'm thinking about and talking about actually at conferences. So there's a lot of things to discover actually. So normally when we are at conferences, even not in person, we have some Q&A session, which is in this case not possible. Sorry for that, just give me a ping on LinkedIn, Twitter, and anywhere else you will find me, or via mail. You find this information in the slides at the beginning. And if you have questions, hopefully I have some answers. And for now, I have to say thank you and goodbye, and enjoy the rest of the conference or the summit so far. Thank you for listening to my little talk about API 6 Ops. Thank you.